Okay, friends, in this video we will discuss previous year questions and we will try to solve them. उनके आंसर्स अपन करेंगे. So you would like this video. So let's start questions and answers which were asked in previous year examination. So these are 5 questions which were asked in previous year exam of 2019. The first question is in MOSFET spectra. In MOSFET spectroscopy, sample should be magnetic. That is false or true. ये पूछा गया है कि MOSFET spectroscopy में sample जो है वो मैग्नेटिक होना चाहिए. ये false है या true. तो ऐसा कोई ज़रूरी नहीं है कि मैं जो sample है वो false हो, sorry magnetic हो. So its answer is false. So the sample can be magnetic or non-magnetic, paramagnetic, whatever. कुछ भी उसकी प्रॉपर्टी हो सकती है, बस उसमें मेटल आयंस होने चाहिए और वो मॉस्फेट स्पेक्ट्रा देना चाहिए. So this is thing, but magnetism is not a criteria for the analysis in MOSFET spectroscopy. So its answer is false. Among cobalt 57 and 57 iron, which one act as source in MOSFET spectroscopy? इस क्वेश्चन में एक्चुअली यहाँ पे स्टार होना चाहिए. सो नाउ इट इज एक्साइटेड कोबाल्ट 57. सो अपने को पता है कि एक्साइटेड जो कोबाल्ट 57 होता है, एक्साइटेड कोबाल्ट 57, ये क्या होता है? MOSFET एक्टिव होता है. सो इट्स आंसर इज एक्साइटेड कोबाल्ट 57. The nature of radiation used in MOSFET spectroscopy is. So the nature of radiation. So when we were discussing about MOSFET spectroscopy, I told you that in MOSFET spectroscopy gamma radiations are used. So gamma radiations कहाँ से आती है? Gamma radiations are released from electron capturing method or process. Electron capturing process से क्या होता है कि gamma rays release होती है. Okay, so this is the answer. The gamma radiation. So electron transfer reactions are of order. Basically electron transfer reactions are second order reactions क्योंकि इसका अपन when we write the rate, the rate is written like this, R is equal to K into reductant and oxidant sorry oxidant. ओके, बट अगर आपसे कोई जनरल पूछते हैं, इफ इट इज आस्क्ड जनरली कि व्हाट इज द रेट ऑफ रिएक्शन इन इलेक्ट्रॉन ट्रांसफर रिएक्शन, सो इट इज sorry, order of reaction is second order reactions. But if it is asked with respect to reactant or with respect to reactant or oxidant or reductant, तो उसके रेस्पेक्ट में अगर आपसे पर्टिकुलर किसी में पूछे कि with respect to reactant it is first order reaction, with respect to oxidant only it is first order reaction, but overall reaction is second order reaction. Okay, the ability of group to direct the entering the ligand towards a transposition with respect to group is known as, it is known as a trans effect. Okay, so in trans effect what happens? Incoming ligand, the position which is occupied by the incoming ligand, that is decided by the group which is already present in the species or molecule. Okay, और इन कॉम्प्लेक्स के ऊपर जो ऑलरेडी प्रेजेंट होता है ग्रुप, वो ग्रुप डिसाइड करता है कि आने वाला इनकमिंग लिगेंड विल ऑक्यूपाई विच पोजीशन. सो this is the ability of a group to direct the entering ligand's position or position. So that is trans effect. Now this is the section B. Give the term symbol for V3 configuration. Okay, V3 configuration means D2 configuration. D2 means इसको करने का which is very simple method that first we will draw the orbitals and we will fill the electrons. So there are two electrons. Okay, so what is the value of 2s? plus 1 2 into S क्या होता है? S is the n by 2. N by 2, what is the n by 2? N is unpaired electron, total number of unpaired electron by 2 plus 1 is equal to 3. Okay, so 2s plus 1 is equal to 3. यानी कि spin multiplicity, the value of spin multiplicity is 3. Okay, so just check which option has spin multiplicity 3. So A option and C option has spin multiplicity 3. Okay, now just check whether the value of L or term for L is same or not. So because what is the formula for writing term symbol? That is 2s plus 1 L and J. 2s plus 1 we have calculated already for D2 configuration, that is 3, right? What is L? L is summation of m, summation of m. Okay, summation of summation of m. So it is 2, it is 1, it is 3. So if it is 3, then it would be f term. Okay, so now it is f, it is f. Okay, so in both cases there are spin multiplicity same, value for your term f is the same. So now the term symbol will be decided by the value of j. In first option there is 2 for j, will j for 2 for j, and in third option or C option there is 4 for j. Okay, so now in this case we have to check whether orbitals are half filled or full filled. Now if we will see this orbital configuration, electronic configuration in the orbiter, then we can see that it is less than half filled. If less than half filled, and lowest, if it is less than half filled, less than half filled, then lower value of lower value of j will be term symbol. Okay, and if it is more than half filled, then higher value or largest value for of j is j would be term symbol. So in this case lowest value is 2 and d2 is less than half filled, that's why lowest value for j would be its term symbol. So A option is right option. Second question, the compound which show metal to ligand charge transfer. Okay, charge transfers, there are three kinds of type charge transfers. The first is ligand to LM, LMCT, ligand to metal charge transfer. Second one is metal to ligand charge transfer. Generally ये होते हैं दोनों, है ना? So ligand to metal, it means ligand is transferring charge to metal, and metal to ligand means metal is transferring charge to ligand. So in case of LMCT or oxide, generally oxide show LMCT, ligand to metal charge transfer. So in this case chromium oxide hai, this is chromium oxide, this is mercuric oxide, this is manganese oxide. So these three will show 2 and 3 will show LMCT, ligand to metal charge transfer. But in this case nickel, this is the pi acceptor ligand. Okay, so that's why ऑक्साइड्स जो क्या होते हैं वो शो करते हैं LMCT, बट जो पाई एक्सेप्टर लिगेंड्स शो मेटल टू लिगेंड ट्रांसफर, यानी कि इट विल शो मेटल टू लिगेंड चार्ज ट्रांसफर. So that's why MLCT will be shown by tetracarbonyl nickel tetracarbonyl. So option A is the right option. Cheminophore is a dark purple color due to. So we know that for color of any complex there are two things. First is DD transition and second is charge transfer. Okay, so in case of cheminophore, this is the higher oxidation state of manganese and it is the oxide of manganese. So that's why here would be ligand to metal charge transfer. So B option will be right option. Wilkinson catalyst is used for hydrogenation of alkene. This is well known, Wilkinson catalyst. Now, Ziegler-Natta catalyst is used in which of the following reaction? So, it is used for polymer reactions, and polymer reaction of polymer of alkene. Alkene. If we want to prepare polythene, then we will go for Ziegler-Natta catalyst. Okay, Wilkinson catalyst is based on rhodium. Okay, so let's discuss these questions. First is if a molecule is having both electric quadrupole and electric field gradient value equal to 0, then how many signals in Mossberg spectroscopy would be? So as we discussed in our when I was taking the lecture, that time I told you that if electric field gradient is 0, then there would be only one signal. If electric field gradient or electric quadrupole is there, then there would be two signal. And if there is a magnetic splitting, then there would be six signal. Okay, so in this case answer would be 1. Among cobalt 57, this is repeated question, so it is star, there should be star, so it is cobalt 57, excited cobalt 57, that would be source in Mossberg spectroscopy. In Mossberg spectroscopy, sample prepared should be in which phase? It should be in solid phase. Sample in Mossberg spectroscopy should be radioactive, true or false? No, 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 it is not necessary that sample should be radioactive. It may be radioactive, it may not be, but generally these are not radioactive, so answer would be false. The nature of radiation used in Mossberg spectroscopy is gamma radiation. As I told you already that gamma radiations are used in Mossberg spectroscopy. The correct order for the isomeric shift in Mossberg spectra of iron compound is. So we have to compare iron 2 plus, then iron 3 plus, then iron 4 plus. Okay. So there is no mention that these are higher uh, low spin complex or high spin complex. Okay, so we will we will say that these are, or we will assume that these are high spin complex, right? So in case of Fe2 plus, configuration would be like this. uh, in case of high spin complex, so complex would be like okay, so complex, if we fill the electron in case of Fe2 plus, so we will feel that there are 6 electrons, so 1 2 3 4 and 5. Okay, in case of Fe3 plus, there would be D5, so this is D6, right? Sorry, okay, this is D6, so for D6. Now 1 2 3 4 and 5, clear. In case of Fe4 plus, 1 D4 configuration, okay, 2 3 and 4. Now complete configuration would be 4s, and s electron would be s0, s0 and s0, d4, d5 and d6. Okay, and we know that the formula for calculating or observing finding the isomer shift value is del is equal to k into delta r by r s square. Okay, or delta r, the value of delta r in case of iron is always negative, delta r value. So isomer shift value will be depend on inversely proportional to 1 by s electron density, and we know that s electron density is inversely proportional to number of p electron or number of d electron, right? So since in all the cases s electrons are 0, so now the isomer shift value will depend on d, like number of d electrons. So in which case number of d electrons are more. So in case of Fe2 plus, there are 6 electrons, right? So and s electron density is inversely proportional to p and d electron. So that's why number of 6 electron will decrease the s electron density, and if s electron density is decreased, then overall value would be or towards positive end. Okay, so that's why overall value will be high. So Fe2 plus is highest. So Fe2 plus in case this one. Okay, the first option there is Fe2 plus is given at first position. So that's the option first is, yeah, A option is the right option. Now come to the, for understanding, come to the Fe3 plus. There are 5 electrons, so that's why electron density will be less in the 5 electron as compared to Fe2 plus, right? And similarly Fe4 plus. So S electron density will be highest in case of Fe4 plus, then Fe3 plus, then Fe2 plus, and its inverse reverse order is isomer shift value. So that's why Fe2 plus is highest, then Fe3 plus, then Fe4 plus. So option A is the right option. Now electron transfer reactions are of electron transfer अभी मैंने आपको बताया this is second order reaction, but if it is added in with with respect to reductant or with respect to oxidant, then it is first order. Otherwise this is second order reaction. The ability of group to direct अभी मैंने आपको बताया it is trans effect. So reaction example of cobalt NH35Cl 1 plus plus Hg2 plus, and now it is turned into HgNH3 whole 5 Cl plus cobalt plus 2. Fine. So in this reaction what's happening, the cobalt is being replaced by Hg2 plus, right? So matlab plus Hg2 plus. Fine. So if it is plus, it means what does it mean? It means it is electrophile. It is electrophile. Okay, if it is electrophile, so electrophilic substitution, there is a electrophilic substitution, right? So this is electrophilic substitution reaction. So answer option A is right option. It is electrophilic substitution. For inner sphere mechanism, electron transfer reactions, both the complex should be inert, both the complex should be labile, one should be inert and one should be labile. The rate of reaction decreases with increasing nucleophilic character of bridging ligand. So its answer is one should be labile and one should be inert. And after the reaction, the labile complex is turned into labile. After completion of reaction, labile complex turns into inert complex and inert complex turn into labile complex. So this is the thing. Now state the number of microstats for V3 or D2 configuration. D2 configuration means there are 2 electrons in, okay, so we know the formula for microstats, that is n factorial by r factorial into n minus r factorial. Okay, so what is n? N is the total number of electron can be occupied in the given orbital. Or okay, so there are d. So d in d orbital, maximum number of electrons are 10. So 10 factorial. 10. This is a factorial. Okay. So now r. How many electrons are there in d orbital? So there are 2 electrons. So 2 factorial into n is 10. 10 minus 2 factorial. So 10 factorial divided by 2 factorial into 8 factorial. Okay, अब 8 factorial से I can write here 10 into 9 into 8 factorial. Okay, 8 factorial से 8 factorial खत्म, cancel. 2 factorial, 2 factorial means 2 into 1. So 2, 10 is 10 divided by 2 is 5. 5 into 9 is equal to 45. So answer is 45. Give the term symbol for D2 configuration. I think it is repeated. So answer A, option A is the right option. The compound which show metal to ligand charge transfers. It is again repeated. It is tetracarbonyl nickel and nickel tetracarbonate. DD transitions are electronic because these are related to UV visible radiation. So that's why electronic transition, because UV visible radiation or UV visible spectroscopy is also known as electronic spectroscopy. Scheminophore is dark color. Abhi आपको बताया it is ligand to metal charge transfer. Which of the following doesn't have iron at the metal center? Vitamin B12, hemoglobin, myoglobin, ferrocin. It has iron, it has iron, it has iron center, but it doesn't have iron center because it has cobalt. Wilkinson catalyst is used for hydrogenation of alkene. Organometallic compound used for treatment of syphilis is organotin. I think it is organotin, but I'm not sure that is organotin. I will tell you later. Okay, or I will mention it in comment box. The catalyst used in conversion of ethylene to aldehyde using Walker process. It is palladium based catalyst. Palladium based catalyst PdCl4 2 minus, and co-catalyst which is used as co-catalyst, it is CuCl2. Cupric chloride, it is used as co-catalyst for the same process. Co-catalyst. Ziegler-Natta catalyst used for polymerization of alkane. Now again, cobalt 57 nucleoside is source in MOS4 spectra. If there is no written star mass, there is no mention of star mass, then it is false. If there is star mass, then it is true. MOS4 spectra is related to resonance fluorescence of gamma rays. So MOS4 spectroscopy is also known as resonance fluorescence microscopy. Spectroscopy, sorry. Acid hydrolysis is also known as acquisition reaction. Inner sphere electron acid hydrolysis में क्या होता है? What does happen in acid hydrolysis? The echo complex is formed. Ligand substitution reactions in which echo ligand replaces the existing ligand in the complex. Inner sphere electron transfer reaction is type of, because it is electron transfer reaction, and option is in option electron transfer is also given, so don't be confused. It is redox reaction. Why? Because there is a use of reductant as well as oxidant. What is cis and trans complex? So with the example of cis splitting we can understand. Okay, so pt, this is NH3, this is NH3, this is NH3, this is NH. Oh, sorry. It is not NH3. It is okay. It is Cl. This is a cis plating. Okay, the same ligands are the same side, and this is the trans ligand, trans complex like NH3, PT, Cl. This is Cl. This is NH3. It is trans plating, and this is cis plating. Okay, cis plating is used as anti-cancer agent, but trans plating cannot be used as anti-cancer agent. Okay, first question is state the spin selection rule. Spin selection rule means after the transition, spin must not be changed. Delta S value must be 0. Means if there is a transition like this electron, this electron, this electron, if this electron goes to here, then its spin must remain same. Spin must remains same. Okay, it should not be like this after transition. It should be like this. Okay, so this is delta S must be 0 after transition. Then these transitions are spin allow transition, and if delta S value is not equal to 0, then these transition are forbidden transition, spin forbidden. In D2 system, which transition has lowest energy? Which transition has lowest energy? Now, we have to identify whether it is asked for tetrahedral or octahedral complex. If in question is not, if in the question there is not mentioned that it is octahedral or tetrahedral, then go to option. So there is G is mentioned over here. Okay, so G is mentioned over here. So it means G is always mentioned for octahedral complex. So that's why we will understand that it is asked for octahedral complex. Now, in case of octahedral, if we draw the diagram, orbital diagram, so okay, okay. So first, we will start from right side, D2 tetrahedral. So if it's D2 tetrahedral here, then it is D2 tetrahedral here. It is A2G. It is T2G. It is T1G. So it is T1G. It is T2G, and it is A2G. So it's in question. Question says that which transition has lowest energy in case of D2 octahedral. So it is D2 octahedral. So T lowest energy, no? So T1G2, T2G will have lowest energy. So T1, just find out where it is. T1G to T1G. Okay, so B option is the right. Sorry, T2G. No, not B. It is C. So T1G to T2G will have lowest energy. So DD transitions are, it is repeated, it is electronic. Which of the following is cobalt at the metal center? It is vitamin B12. In hemoglobin there is iron. Myoglobin, it is iron. Ferrocin, it has iron center. Grignard region is made of, it is well known, it is RMgX.